All right, this is video 9.6. We are doing permutations and combinations today. A couple of vocabulary terms. The first thing you need to know is what factorial is. A factorial is going to be the product of all the whole numbers from the number that's given down to 1. For example, 3 factorial is the little exclamation point is the factorial symbol. What that means is you want 3, because that's the number, and all the numbers that are smaller than that down to 1. So it's 3 times 2 times 1. So that would be 3 times the 2 is 6. 6 times 1 is 6. And so 3 factorial is equal to 6. A permutation is an arrangement of things where the order is important. And a combination is an arrangement of things where the order is not important. So there's a difference between permutation and combination. Combination, if we're doing combinations of the first 3 letters of the alphabet, it doesn't matter what order they're in, that would be a combination. Permutation means that they have to be in a specific spot in that order. All right, so let's evaluate some expressions containing factorials. So 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You can do it the long way, or you can put it on your calculator and just type in 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or if you have a calculator that has the exclamation point or X exclamation point, you can put it in that way. So this one would come out to 362,880. If you have a division problem with factorials, when you write them out, you can actually do some reducing, so it'll make it easier. So like that 3 will reduce with that 3, the 2 with the 2, the 1 with the 1. So all you're really looking for is 6 times 5, which is 30, times 4, which is 120. The other way you can do it, if you have any kind of PEMDAS that needs to happen, so we will take care of what's inside of our parentheses before we do our factorials. So this would really be 14 factorial over 7 factorial. So if you put that out, our 7 through 6 down here will cancel out our 7 through 6 up there. So all we're really worried about is 14 times 13 times 12 times 11 times 10 times 9 times 8. And that would be 17,297,280. You can see where a calculator will come in handy, because some of these really big factorials, it would be very easy to make a mistake if you're trying to do it by hand. So let's talk about permutations. Let's say we're taking the first 3 letters of the alphabet. We want to know how many different ways we can arrange those first 3 letters. Permutation means that the order is specific. So we could have ABC, we could have ACB, we could have BAC or BCA, or CAB or CBA. So there are 6 different ways to arrange the first 3 letters of the alphabet if we're looking for permutations. The formula for a permutation is going to be this, where n is our number of things. N is the number of things. So in this case, we're looking for 3 letters. And the R is what, how many things we're using. So the way it says is like R is the number taken at a time. And hopefully that'll make more sense as we do a couple of examples. So in this example here, we are taking 3 numbers and we wanted to take all 3 at one time. So let's say if we were saying the first 5 letters of the alphabet and we were taking 3 at a time, then our numbers would be a little different. So our n factorial goes on top, and then our n minus r factorial goes on the bottom. So in this case, you've got 3 factorial over 3 minus 3 factorial, which would be 0 factorial. Here's where you need to remember. 0 factorial is always equal to 1. So in this case, we would have 3 times 2 times 1 over 1, which is 6. And that works out to 6 ways to order the first 3 letters if we take all 3 letters at a time. So let's say there are 8 runners in a race. We want to find the number of orders in which the 8 runners can all finish. So we're taking all 8 runners in the time to finish it. So our n is going to be equal to 8, and our r is going to be equal to 8. So we'll have 8, P8. The P stands for permutation. We want our n factorial, which is 8 factorial over 8 minus 8 factorial. So what I'm really looking for is 8 factorial over 0 factorial, which is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1. And 8 factorial is 40,320. There are 40,320 ways that those 8 runners can come in and finish that race. Let's say we're taking our 8 runners and we're not worried about places 1 through 8. We are only worried about first, second, and third place. So in this case, the number of runners we have is 8, and the number of runners we're wanting to count is only 3. So our R is different this time because we're only looking for the first 3 finishers. So here we'll have our 8P3. So in factorial, so it's an 8 factorial over 8 minus 3 factorial. So our 8 factorial over 8 will be 8 factorial over 5 factorial. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Don't need to worry about those right there. All I'm worried about is my 8 times 7 times 6, which is 336. So there's 336 ways that the top 8 or the 8 runners can come in first, second, third. So the difference between a permutation and a combination is this. Remember that combination, the order doesn't matter. So remember in our permutation, we had 6 different ways we could combine the first 3 letters of the alphabet. If we were looking at that again as a combination, that would be 6 different permutations, but it's all one combination because order doesn't matter. And so this is the formula for a combination. We still have our N's and our R's. It's very similar here. This is the part that's different. We'll divide by another R factorial. So if we were to take this, we were to say our N is 3. We have 3 letters, and we are wanting to take 3 at a time. So we'll have our 3 factorial on top because that's our N. We have another 3 factorial on bottom because that's our R. And then 3 minus 3 factorial, that's N minus R. So 3 factorial is 6. 3 factorial is 6. 3 minus 3 is 0. 0 factorial is 1. So that's really just 6 divided by 6, which is 1. So while there are 6 permutations, there's only 1 combination for this set. So let's say we would go to a gourmet pizza restaurant and there are 9 topping choices. We want to find the number of 2 topping pizzas that can be ordered, right? So we have 9, so our N is 9, but we only want 2, so our R is 2. So when we set this up, we're going to say N, C2. Remember, it's N factorial on top, so I'm going to do 9 factorial on top, my N factorial on bottom, times my N minus R. Oops, I put R instead of 2. Factorial. So that'll be a 9 factorial on top over 2 factorial times 7 factorial. So that would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So these 7s and those 7s cancel out. That 2 and that 8 would become a 4. My 9 times 4 will be 36. So there's 36 different pizza combinations for ordering a 2-topping pizza out of these 9 pizza choices. Let's say how many of the 5-topping pizzas can be ordered. So once again, our N is still 9 and our R is 5. So we'll have 9C5, 9 factorial on top because that's our N, 5 factorial because that's our R, and then N minus R factorial. So that would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. Why did I do a 4 right there? Sorry, little mistake. That shouldn't be a 4. That should be a 5, which means that this is a 4 factorial. cancel those out. This 3 times 2 is, cancels out that 6 right there. My 8 can cancel with my 4. So that will leave me with 9 times 2 times 7, which is 126. There's just 126 combinations of 5-topping pizzas that could be ordered. Go ahead and click on the link, complete the homework assignment, and I'll see you in class.